Okay, in this video I am going to show you how to label right angle triangles so that we are able to calculate the lengths of the sides, whether it will be the opposite side or the adjacent side or the hypotenuse, or it would be finding one of the angles bounded by the hypotenuse and the adjacent side, bounded by the hypotenuse and the opposite side. So let's have a look at a right angle triangle now. Okay, and I'm just going to draw this, see if it snaps to the grid. Okay, so we have a right angle triangle over here. I'm just going to change the pen to black color. Right, so if I have this angle over here as angle theta, then this side, the longer side of the triangle, as I've said before, is called the hypotenuse. And we'll label this as capital H. This side over here, which is opposite to the angle theta, this is called the opposite side. How does it do that? Opposite side. I'm going to label this using the letter O. And this side, the side that is adjacent to the angle theta, so it's going to be labeled as, so I think the best thing for me to do is to color code this. So I'm just going to highlight this using that. So this side over here is the adjacent side. So that is the adjacent side, and we'll label this as A. And this side, which is the opposite side, I am going to, if I can highlight that black over here, that bit over there, that is the opposite. So this opposite side. Okay, so we need to understand that if we have angle theta, the side directly opposite to that is called the opposite side, and the side which is beside the angle theta is called the adjacent side, and the hypotenuse of a right angle triangle is the longest side of the triangle, of the right angle triangle. Okay, so what I'm going to do now is I am going to actually show you how these are used to calculate the sides. So this got a pen. So the first one that I'm going to look at is, if I have a right angle triangle over here, didn't like it. Let's try again. Okay, that's better. Right, so let's set this as angle theta. That is the opposite side O. This is the adjacent side. That is the hypotenuse. So from here I can write one rule which is called sine of angle theta is equal to opposite divided by the hypotenuse. So if I write this in full, it is opposite that side divided by the adjacent side. Now, in short, this will be written as sine theta is equal to O over H. And I think it is very, very important for you to remember this rule. And from the same triangle, I can also get this rule. Cos of theta is equal to the adjacent side divided by the hypotenuse. And so this is going to be simply written as cos theta is equal to A over H. This is another important rule that you need to be able to remember. Okay, and the last one from here is called tangent theta is equal to opposite divided by the adjacent side. And in short, we write this as tan theta is equal to O over A. And this again is another important rule that you need to remember. So we have to use these three different rules over here to actually work out the length of the sides of a right angle triangle and the angles as well. So what I'm planning to do is first example I'm going to do is calculate the this example over here says calculate the opposite side in the right angle triangle shown below. Now I have three different rules to actually choose from. One is sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tangent theta is opposite over adjacent. So to actually calculate the opposite side over here, which rule should I use? So only thing I can figure out from here is I just want to go and see what is given to me. So let's just go and see what rules I have over here. I have sine theta is equal to that, cos theta is equal to adjacent over hypotenuse, and over here we've got tan theta is equal to opposite over adjacent. Okay, so let's see what's given in each rule and what we are supposed to find. And I'm just going to use a highlight over here. Ooh, what happened here? Try this again. I'm just going to choose the orange one. So, do I know the hypotenuse? In here is and the hypotenuse. I've got the hypotenuse over here as well. Okay. Do I have the opposite side? Yes, I'll have to calculate the opposite side. And do I have the angle? Yes, I have the angle over here. Whereas over here I have the angle, but I don't have that, the adjacent side. In other words, if I can actually choose a pin here, let's try this. So I don't have that. I don't know what the adjacent side is. So I can't use this. Can't use that. And over here, although I have the angle here, I have the opposite side, but I don't have the adjacent side, so that I can't use this either. So the one that I'm going to use is this one over here. So you will need to decide what is given to you and what is not. So looking at now, I'm going to use sine theta is equal to opposite over hypotenuse. So let's substitute. So I have sine and angle 30 degrees is equal to opposite side is x and the hypotenuse is 25. Okay, so I want to find the value of x. So what I need to do is, how do I undo the 25? So I need to multiply both sides by 25. So that means this is going to become now 25 sine 30 degrees is equal to x over 25 times 25. So remember, I said to you that I need to multiply that side and that side by 25. So when you do that, you will notice that so what you'll notice is that 25 basically just cancels with that, and you're left with x is equal to 25 sine of 30 degrees. That means 25 times sine of 30 degrees, that part over there. If you do this on the calculator, you'll find that gives you 0.5. That gives me 12.5 centimeters. So the length of the opposite side is going to be 12.5 centimeters. Okay, so the next thing that I would like you to have a look at is calculate the length of the adjacent side in the triangle shown below. So in this case, you are given the hypotenuse, the angle is 30 degrees again, and the side marked y is the adjacent side. So out of the three rules, so the sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over a. Out of these ones over here, I can use only one particular rule. So let's see what is available to us. So what has been given in the question. Now there is no opposite side given, so I can cross those out. Hypotenuse is given there. Okay, I have to calculate the adjacent side. I have the angle. I have the angle. So over here, I'm calculating this over here. So in this over here, you can notice I have got 3 ticks, whereas in the other I have only 2 ticks. So that means I can't use this, I can't use this, I can use this. So to go and answer that, cos theta is equal to adjacent over hypotenuse. So cos of 30 degrees is equal to adjacent side is y, the hypotenuse is 15. Now what I'm going to do is instead of multiplying both sides by 15 and doing all that, I'm just going to keep it very simple. I'm just going to go, I know that if I want to find this y over here, I can just go and go 15 times cos of 30 degrees is going to be y. But if you want to multiply both sides by 15 and do it that way, that's fine. So this over here, y is going to be 15 times cos of 30 is going to be 0.8660. Now you will need to use a calculator to actually work out what is cos of 30, and when you do that, make sure your calculator is in degrees mode, not on radians mode. So this will give me an answer of, so if I do this on my calculator, 15 times 0.8660, it gives me 12.99. That is very, very close to 13.0. So I am going to say that the answer for that is rounded to 1 dp, or